Hello, this is Jim with We Develop Electrical Products. This is our 9th project with the Arduino. Today we're going to be talking about pull-up and pull-down resistors and how you select the value of those pull-up and pull-down resistors. This schematic I've got here shows a couple of pull-ups on an AND gate. We'll just assume that these are inputs to the Arduino. So there's two inputs here, and we've got a couple of resistors going up to 5 volts right here, and then they're tied to a push button that goes to ground. So what we're assuming is going to happen here is there's going to be a voltage applied to this pin. It's going to be some proportion of this 5 volts, and when you push this button, it's going to pull this pin low and changing the state. Now, if you didn't have a pull-up resistor here and you just had it tied directly to ground, that wouldn't do you any good, because this pin would be floating, and any noise that you have in the area is going to get on this pin, and it's going to change its state from a high to a low. If we go to the at Mega 328 for the Uno and look at the DC characteristics of that Uno, we see that for a low voltage, the max that you can have is 0.3 times VCC. And VCC in our case is 5 volts, so 0.3 of 5 is 1.5 volts. So the max you can have on that input pin and be defined as a low is 1.5 volts. So you can see that if any noise gets on that pin and it goes over 1.5 volts, it's going to be on an unknown state, and it could be flipping between a high or a low. Now, the high is defined as a minimum of 0.6 of VCC. So 0.6 of 5 volts is 3 volts. So you have to have a minimum of 3 volts in order to be defined as a high and be stable as a high. So if we're going to have a high voltage, we want to make sure that we stay between 3 volts and 5.5 volts, this VCC plus 0.5 volts. If we're going to have a low voltage, we want to make sure we stay between a minus half a volt and this 1.5 volts. And then we're sure that we're going to have a low voltage and a high voltage. So now how do we get to the value of this pull-up resistor? We know that we want to have at least 3 volts here to be defined as a high, and that's what we want to hold it at, as a high, until we push this push button, and then it'll pull it low. So how do we get that value of 10K? Well, we could go to the Arduino digital pins and search out pull-up resistors and pin configurations, and they've got right in here that if you're going to use a pull-up or a pull-down resistor on the input, then a 10K resistor is a good value for a pull-up or a pull-down resistor. Now, how did they get to that value? Well, if we go back to our schematic for the pull-up, we could figure the internal voltage drop, because if we throw a 10K ohm resistor in there, then we've got a current right now of 0.5 volts because we're going to hold this. We're going to assume that we hold this at 4.5 volts so that we're well above that 3 volts. Then we're going to have 0.5 volts drop across this resistor because we got 4.5 here and we got 5 up here. So that means we had to lose a half a volt across that resistor. So a half a volt divided by 10,000 ohms, that's Ohm's law, is going to equal to 50 microamps of current going through here. So if we got 50 microamps of current, we can figure the internal voltage drop. Now, if we go to the Atmega again, chip, and we scroll down in this, it's talking about input leakage current for both a low pin and a high pin. And that input leakage current is a maximum of 1 microamp. So if it's held high, there's going to be leakage going into that input on the Atmega of 1 microamp max. So that tells you something about the internal resistance. If we go down here and we say, okay, what is our internal resistance? We've got 1 microamp of leakage current, according to that spec, at a high input of 0.6 of VCC. In other words, we've got 1 microamp of leakage current at 3 volts. That's the low level that you can have for high. Then what would the internal resistance be? Well, by Ohm's law, it'd be 3 volts divided by that 1 microamp, or 3 mega ohms of resistance internal to our chip. So we're getting 1 microamp of current going through here because we've got 1 or 3 mega ohms going into that chip. So now if we say we've got 5 volts at this point up here, then we've got 10K and a 3 meg resistor going to ground. So it would be to figure out what the resistor should be, or what the voltage is going to be at this point right here. Then you just take 5 volts divided by 301 kilo ohms, and that's going to be equal to 1.66 microamps of current going into that device when it's sitting with the 10K ohm resistor. So all we did is took the 3 mega ohm resistor and added the 10K ohm resistor to get this value down here. So 5 divided by that, by 3,010,000 ohms, is going to equal 1.66 microamps going into our input. So now that means that the voltage at this point is going to be equal to our 3 mega ohms times 166 microamps, or 4.98 volts. So we're going to have 4.98 volts here, and that's well above our 3 volts. So we're okay. So that 10K ohm resistor is fine for having for that. Now, that's a long-winded story about how to get to the value. But if we go back again and look at the Arduino pin modes, we see that the Arduino has a pin mode that we can set for input underscore pullup. So we can set, there's an internal pullup resistor inside the mega chip on our Arduino, that if we do a pin mode of a pin and set it to an input underscore pullup, it's going to throw a pullup resistor in series with that. Now, what is the value of that internal pullup resistor? If we go back here on the I/O pins, and these are all the I/O pins, even the analog pins, inputs can have a pullup resistor on it. If we just give it that pin mode input underscore pullup, it's going to be a value, the pullup resistor is going to be valued somewhere between 20 to 50 kilo ohms. So they already have a pullup in there for us, but sometimes you're going to want to use your own pullup resistor for one reason or another. And so that's just the reason we're going through this discussion on how to determine the value of a pull-up or a pull-down. And now a pull-down resistor, if we take a look at what a pull-down resistor does, this is a schematic of a pull-down resistor. We just have a 10k ohm resistor tied to ground, and we have it going to the pull-up resistor. I mean, it was tied to the pull-down resistor. So if you push this switch, you're going to pull it up to this VCC or our 5 volts. So how do you figure out the value of that? Well, we're just throwing in a 10k ohm resistor because Arduino advises we use a 10k ohm resistor. But we can look at it this way too. We've got that leakage current, remember, for a low of 1 microamp. And the low max is 0.3 volts, or 0.3 times VCC, or 1.5 volts. So if you have V2, what's the V2 going to be? Right there. You've got the 10k ohm resistor times 1 microamp, or 0.01 volts is going to be right here. And that's well below our 1.5 volt max that we can have there. So that says that resistor is fine to use for that. So that's how you kind of come to a value of a pull down resistor. You throw in a value and you see if you can stay below that 3 volts that was on the specification. So this was our 9th project on the Arduino, figuring out how you can come up with values of pull-up and pull-down resistors for the inputs, and why you would use them is so you don't have floating pins and them going floating between unknown states and causing your output to oscillate between ones and zeros. So if you like this video, please hit the like button. That'll help me out. And subscribe to the video. And hope you have a good time with the Arduino. And enjoy yourself. Have a good day.